Here's a question where we have a function given in a specific context so that we can interpret things like the horizontal asymptote in the context. So there's a formula here given that is going to express the concentration of sugar in a tank after 10 minutes. So the input here is T for measured in minutes, and the output is going to be the concentration of sugar in the tank. So we can certainly evaluate this function like a normal function. So the first question here asks us about C of 12, and so this is just to remind you that that means that we're going to put 12 into the function. Good grief, I'm in trouble getting my pen. C of 12 is going to mean that we're going to look at the definition of the function, and everywhere we see a T, we're going to write 12. I don't know why I'm trying so hard to get my pens. Anyway, so 8 plus 3 times 12 in the numerator, and 80 plus 15 times 12 in the denominator. And so with our calculator, we can just find out that is 8 plus 36 is 44 in the numerator, and 80 plus 180 is 260 in the denominator. And if we put that in a calculator and round it off correctly to 3 decimal places, for this particular problem, I would enter 0.169 as my concentration. So that is the units for that are pounds of sugar per gallon of liquid. And so the answer you'll see here is pounds per gallon will be the right units for concentration. The horizontal asymptote is, we can find that for our formula without any kind of context. We know that as T gets really large, and so this means as time goes on, as time gets, year from now, 3 years from now, 5 years from now, T getting very, very large for time, my rational expression is going to look more and more like, I'll write this way, so I'll say approximately, so the expression will look more and more like just the ratio of its leading terms. So that's our theory for horizontal asymptotes, is we have polynomial over polynomial. I can identify the leading term, in other words, the highest degree term in the numerator and the highest degree term in the denominator, and that's what's going to dominate that polynomial. So as T is going to infinity, these two things are getting closer and closer and closer together. And that's what the horizontal asymptote is reflecting. And of course, the algebra here would allow us to cancel these T's, and 3 and 15 is 3 times 5. And so we could do a little bit of algebra of canceling things. So I'm going to cancel those. I'm going to rewrite 15 is 3 times 5 and cancel the 3, and I'll have 1 over 5. So as T goes to infinity, meaning T goes way, way out to the right, the outputs of this function are getting closer and closer to 1/5. So that is going to be our horizontal asymptote. Of course, to 1 over 5 is 0.2, so 0.200. And the interpretation there, because we're saying as T goes to infinity, that means over a long period of time, the outputs, and of course the outputs are concentrations, the concentration is getting closer and closer to this. So after 12 minutes, the concentration is 0.169, but if we just let the clock keep going and the time goes to 100 minutes, 1,000 minutes, 1,000,000 minutes, the outputs are going to get closer and closer and closer to just 0.200. So the correct answer to the last box is that over time, the concentration is settling down on about 0.200 pounds per gallon.